Hello viewers, today we'll see about real numbers, chapter 1C. This is for CBSE board. Question 1. Show that each of the following rational number is a terminating decimal. So what is rational number? P by Q, let's assume, where P and Q both are integers, but Q is not equal to 0. So whichever satisfies this condition, they all are rational numbers. It can be even minus 1 by 2. As we mentioned, it's integers and also 0. So 0 by anything is again 0. So 0 is also a rational number. An irrational number is the one which does not satisfy this condition. The square root of 2, square root of 3, even the value of pi, 3.14, all these are irrational numbers. But here it's mentioned as terminating decimal. So let's take an example to explain this with a simple fraction 1 by 4. So which will have a decimal value of 0.25. At 5 it is completing. The remainder is 0. But if you see 1 by 3, it goes on 0.3, 0.3333 goes on. So which is not terminating, which is not ending. So the rational number with the terminating decimal is what? We're going to check for this question 1's condition. So here P by Q is an integer and Q is not equal to 0 for the rational with the satisfying condition. The decimal terminates. Question 1. 23 by 2 to the power of 3 into 5 to the power of 2. So 23 is not a factor of 2 and 5. So that's the first thing to check. It's already in the simplest form. Next, it's a form to the power of m into 5 to the power of n. So that's the second condition. It satisfies. And when we divide this fraction, the value in decimals, is it terminating or not is what we're checking. That's 0.115. So yes, this particular fraction terminates. Same way 125 can be written as 24 by 2 to the power of 0 into 5 to the power of 3. 5 5s are 25, 25 5s are 125. So that's what 5 to the power of 3 means. And 2 to the power of 0 is 1. So again, it's a form 2 to the power of mn, 5 to the power of n. So when we do the decimal, fraction into decimal, it is 0.192. So that's also terminating. Third is 171 by 800. 800 can be written as 2 to the power of 5 into 5 to the power of 2. So 2 5 times is 32 into 5 2 times is 25, which is 800. It's a form 2 to the power of m into 5 to the power of n, and it's not a factor of 171 is not a factor of 2 and 5. It's already in the simplest form. And when we do the fraction to decimal, it is, yes, it is terminating, 0.21375. Next, 15 by 1600, which can be written as 15 by 2 to the power of 6 into 5 to the power of 2. And it's a form 2 to the power of mn into 5 to the power of n. And the decimal is terminating, 0.009375. Next is 17 by 320. 17 by 320 can be written as 2 to the power of 6 into 5 to the power of 1. So it's a form 2 to the power of m into 5 to the power of n. Here it is 1. 5 to the power of 1 is 5. Whereas 5 to the power of 0 is 1. Just for the understanding and the exact difference. And 17 is again not a factor of 2 and 5. It's already in the simplest form. Now let's check whether it's terminating. decimal. Yes, 0.053125. Next, 19 by 3125 can be written as 19 by 5 to the power of 5. And 2 to the power of 0 is nothing but 1. It's a form, it's not a factor. 19 is not a factor of 2 and 5, as well as it's a form 2 to the power of m into 5 to the power of n, and it also has a terminating decimal. Next question, without actual division, show each is not a non-terminating repeating decimal. 11 is not a factor of 2 and 3, but 2 to the power of 3 into 3 is actually not of the form 2 to the power of m into 5 to the power of n. So this is non-terminating repeating decimal. Second one is 73 by, again if you see the denominator, it's not satisfying the condition of 2 to the power of m into 5 to the power of n. So that clearly shows this is a non-terminating repeating decimal. You can cross-verify by doing the calculation. You're dividing the numerator by denominator. It will have the repeated decimal value. Never ending. Again, for the third one, it's not satisfying the condition. The denominator is not of form 2 to the power of m into 5 to the power of n. So that clearly shows this is also not a terminating repeating decimal. 9 by 35 can be written as 5 into 7. This again denominator does not satisfy the condition, as well as it's not a factor of the, it's already in the simplest form. So this is also non-terminating repeating decimal. Next is 77 by 210 can be written as 77 by 2 into 3 into 5 into 7. This is again not satisfying the condition. You can see the factors how we are getting. 5 times 105, 21, 7 times 3, 3, 1 time. So these are the factors. And it's not satisfying 2 to the power of m into 5 to the power of n. This is also not terminating repeating decimal. Next, 32 by 147, which can be written as 32 and 147 can be written as 3 into 7 to the power of 2, 49 into 3. So this is again not a form 2 to the power of m, and it's 32 is not a factor of 3 and 7, so it is already in the simplest form, but it's not a form 2 to the power of m into 5 to the power of n. So this is also not terminating. Next question 6. So again, 29 is not a factor of 7, but 7 cubed doesn't satisfy the condition of 2 to the power of m into 5 to the power of n. So this is also never ending repeating decimal. Next, 64 by 455. 455 can be written as 3 into 7 into 13, and all 64 is definitely not a factor of any of these numbers in the denominator. It's already in the simplest form, but the denominator is not satisfying the condition of 2 to the power of m into 5 to the power of n. So this is also never ending, not terminating repeating decimal. Question 3. Express each of the following as a fraction in the simplest form. 0.8 and 8 is repeated continuously, repeatedly. So let's assume it as x. Then 10x is 8.888. It goes on the same way. Let's assume these two as 1 and 2 equation. So by subtracting 1 from 2, if you see 10x minus x is 9x on the left hand side, and right hand side is just 8. So x equal to 8 by 9. And the answer is required as a fraction in a simplest form. It's not further divisible. I can write it only. Next, second question is 2.4 is repeated, not terminating. Let's assume it as x. So 10x is 24.444. Again, by considering subtracting these two equations, 1 and 2, 1 from 2, we get it as 9x left hand side. 24 minus 2 is 22 right hand side. So x equal to 22 by 9. This is the simplest form, which is not further divisible. So 4 is endlessly repeating. That's what it means. Next, 0.24. So x is 0.24. 24 is repeated continuously without terminating. So 10x is 10x is 2.4. So 100x is 24.2424. So if you see here, this as equation 1 and equation 2, it's going to be 99x equal to 24, x equal to 24 by 99, and goes in 8 times 3 table, 33. So this is the simplest form for 0.24, which is not terminating. In next one, if you see, the condition is only 2 is not terminating. So it's x is 0.122222, and 10x is 1.222, 100x is 12.222. So let's take 10x as 1 and 100x as 2. By subtracting, we get 90x 100 minus 10 left hand side, and 11 and right hand side. So x is 11 by 90, which is the simplest form for the 0.12, which is not terminating decimal. Next, 2.24, if you see, here again 4 is only repeated. X is 2.244444. 10x is 22.444. 100x is 224.444. Let's take 10x and 100x as two equations. By subtracting, we get 90x left hand side and 202 right hand side. So x is 101 by 45. That's for this non-terminating repeated decimal force, 2.24 fraction form. Next, 0.365. 65 is repeated here. So 6565. Next, 10x is 3.65. 100x, 1000x is 365.6565. It goes on. Now by subtracting 10x and 1000x positions, we get 990x left hand side, and right hand side is 362. So x is 362 by 990. Further simplifying, we get 181 by 495. So that's for 3.365, which is not a terminating decimal. Hope this is useful. Thank you.